Welcome back to the table. Everything we need is right in front of us this time. This over here are the parts for our engine gimbal. 3D printed them, they actually turned out quite well. And up here there are all the screws and bearings and the tools we will need for the job. And right here we have the blueprint. It's a little bit rudimentary, so don't take this as is. It's just for me to find at which position I have to put which screw. Let's start off by putting in the ball bearings. These ball bearings are 4 mm in diameter on the outside and fit snugly into the print-in holes for the outside gimbal. But as most of you know, 3D printing is not always exactly on point, so most likely these will not just fit in there, and we will have to take this knife over here and scrape out a little bit of the 3D printing material to fit in all the bearings. I just have to be careful that I do not scrape out too much material, because the bearings will only be stuck in there by friction. Obviously we will not have this kind of a problem when we machine these parts for metal. For now we will have to deal with them. That is one in. Let's check if it's still turning in the middle. Yep, still moving. What might happen is that I put them in, there is too much radial pressure on them and it will squeeze them so much that they do not turn properly anymore, because I just noticed that I indeed have to put in so much pressure that I leave dents in my beautiful wooden table. I will just use this metal piece to press upon, so that's a way I do not leave any dents in my beautiful wood table. This one was a little bit more resilient, but it's in and it's turning smoothly. Just 2 more to go. These ones are a little bit trickier, because while these ones are on the outside, these ones will be on the inside. There we go. The issue of these inside holes is an engineering problem I still have to find a solution for. In this case it's a little bit trickier to reach and put the bearing in. It also is pretty much impossible to properly machine it. These ball bearings need some kind of a stopper at the end of the hole. There is a little lip on the end of the holes, so the ball bearing is being pushed against that. That's why they also sit so smoothly and snugly in there, because they cannot go any further, which is most important with, for example, metal, because when the holes are exactly on point with a very small tolerance, the ball bearings will not be stuck in there like in the plastic, but they might just fall out, so we most likely have to glue them. But we also really need that little part, the little flap at the end of the hole. So the inside hole must be bigger than the outside hole. How are you gonna get a drill in here to drill a bigger hole than this hole already is? But for now, we're gonna work with it. So all 4 ball bearings are in their holes. Let's have a short look at the blueprints. So this part down here now has its ball bearings in. The next step is using these side parts and putting them into the ball bearings on the side. Same problem though, 3D printing is always a little bit bigger than it's supposed to be, so I will have to cut them down around the sides as well. In general, I have to be far more careful with this part, because the little stick in the middle is far flimsier than a huge amount of material we have around here. So if I am a little bit too motivated to put it in while it's not the right size yet, I will most likely just break it, and then I have to 3D print it again, and that will delay stuff and will be a pain, and I really do not want that, so I'll rather be careful than fast. Okay, looks like we got it in there quite fine. This seems to be right the edge I wanted at. This is something I really do not want to see. This is what I was talking about earlier. I put in the ball bearing at too high pressures, and it always wants to get into the state where there is the least amount of pressure built up inside of it, which is on this side, so it essentially acts like a spring. Okay, lots of carving later. As you can see, there's quite some spring force in there still, but at this point I'm scared of the ball bearing to sit too loosely, and also the force I have to put in to move this part is so far down now that yes, it does do this, but as soon as we will have our linear motors, which are working with forces of up to 300 newtons on this thing, it will be neglectable. And I will just say this is okay and move over to the next part. So I also have to cut down some material from this. Annoyingly, I just broke one of the 3D printed parts off camera, so we will have to wait for a second for the glue to cure over there, but that doesn't really matter. We can just keep on building. We'll just jump right ahead to the next step, which is fitting in the upper and the lower ring. The upper ring's job will be to convey the forces from our rocket engines to the rest of the gimbal. You can see two 38mm diameter grooves on each side where the rocket motors will fit snugly. The lower ring will mainly be for stability and keeping the rocket engines parallel and straight. We'll start with the upper ring now. For the 2mm diameter torque screws we're going to use, we'll have slightly bigger holes in the bars than in the rings. That is so we can just push these screws straight through the bars, but there will be a lot of material on the rings where we can cut a thread into. Let's get ourselves a screwdriver over here. I'll try to put in both at the same time. I do not know if one of them will just fall out. We will find out. Always put in all the screws first before you tighten them. Otherwise you might build up tensions because the part wasn't perfectly straight yet. That might damage the part in the long run, especially when you're dealing with something rather soft like this PLA plastic. There is one rule of thumb. In German we say nach fest kommt ab. So in English that would be after tight it's off. Put in the screws too much, you most likely will break the material, and after you have them in tight, they will just fall off. So now the glue and the ball bearings are mostly cured. We'll have to put in a little break till it is completely cured. I really do not want to risk it to break off again. Around 20 minutes are over. The part looks as new, ball bearing still turning, so I did not glue that all together and unmovable. So I will put it in there and hope that I don't break it again on the way there. Looks like we are fine. Let's put that first screw. Now we're back to slowly and carefully tightening the screws. Next up, the lower ring. If it still fits in there. Same procedure as at the upper part, putting in 4 screws. Now misalignments in the 3D printing really start to show. Doesn't matter, you can bend it slightly. It will not do a thing to the PLA plastic. I don't see a reason why this should go wrong in any way, shape or form. And I already regret saying that because that's usually the last words before everything goes down the drain. Went straight in. It's beautiful. The second you hear the tightness, it's already too late. So this is our engine bay. You can tell one of the rings really wants to go one direction because of that slight spring force that is in the ball bearing because of my slight misalignment, but who cares? You might notice the servers are still missing, and we're going to do that right now. There's a hole down here and a part up here, same mirrored on the other side, for 2 PQ12 engines to be mounted. For that we also need these little extensions, because the PQ12 is not long enough to span the whole width. With the PQ12 and same with the P16, there is a bunch of different parts that will be shipped with them. We only need these brackets. I also got fitting screws. These brackets will be mounted to the top part, and the bottom of the PQ12 will be mounted to this extension. So we will start off with fitting these brackets. Now, as the screw is pushed through the hole that technically is bigger than the screw itself, we will hold it from the other side. Mind you, we will be using 2 of these, so there will be a play down here. This is to make sure that there is no unnecessary tension on the engine gimbal. Also, I will only be mounting one of these brackets, not on the other side, because currently we only have the electronics for one PQ12. On the bottom there is this bracket that will also be fixed with a 2mm screw. Let's now screw in the extension. Not too tight, we do want some room to wiggle for it. And now, last but not least, the PQ12 I nicked from the electronics, which we built yesterday, so check that out. First we will mount the bottom to the extender. This connection has to be very tight, so we really do not want any play to be possible here. Now we go to the upper part, we put our screw through, and then screw it. Not all that tight, we also want some play up there. And that's already it. That's the inner part of our gimbal. The only thing that is left is putting on the big P16 linear servo. But I will do that when I fit this whole construction into a test stand, which I plan to build from Lego Technic parts. In the test stand we will be able to test this gimbal assembly with code running on it, and as soon as that works we can move on to the next part of the rocket. There is still a lot of things to cover, even though our TVC gimbal is one of the most difficult parts in the rocket. So look forward to part 3, which will be coming out soon. Thanks for watching, I hope to see you the next time with our test stand, and bye bye!